Hi, this is Module 7 Video 2. In this video I'm going to take you through some infrastructural and utility code that I've put in place for the views layer. So what I've done is added a bunch of code that I've written for previous projects and set up the kind of startup of the application the way I would usually set it up. So I'm going to take you through the bits and pieces that I've added and explain what each of them does. I'm going to start with this appearance manager. So what I've got here is I'm setting up for different controls. I'm setting up kind of default properties, if you will. So the default status bar style is light content, and down here I've got default title colors for the buttons, dependent upon their control state. Now you'll see as well I've got this resources class which I've added, and I've just added in a bunch of kind of theme colors. I've chosen kind of a yellowy theme. So we'll see how that turns out, but that's what we're going to run with for now. And obviously if I need to change the color, I'll just come to this one spot and change it there. Now unfortunately the appearance management subsystem in iOS is severely limited. There's key critical properties that are missing that you just cannot configure through the appearance manager. So there's only so far we can take this code, and I've done the best I can here to kind of set up the defaults that we want. But beyond that, I've also got this control factory class, and the idea of the control factory class is that for every control we need in the view layer, we'll call into a method on this class to create it, and it will give us back a control with all the default properties that we need. So for example, when we create a text field, which actually I don't think we'll need in this application, but I've taken this code from another project where I did need it. I've set up the the auto correction and capitalization stuff that I wanted to set up, which I can't do through the appearance manager. Even the border style, you can't do that through the appearance manager. So that's an example of why the appearance manager is so limited. Now the other thing I'm doing from this class is creating subtypes of the actual type that's being requested. So for example, when you request a label, it returns back this dynamic type aware label, which is an inner private class here that extends UI label. And basically it takes this dynamic type changed observable, so it knows when the user has changed the dynamic type size, and when they do, it can update the font automatically. So by using the control factory, from our views, we're automatically getting this behavior of allowing the user to change their dynamic type size, and the view will refresh automatically based on that, assuming we've used layout correctly, which we'll get to in a second. And that's true of all these controls. Like dynamic type aware button does a similar thing. Now I've also got this preferred font enumeration, which you can pass in a value to when you're creating the control up here. And the idea is that iOS has some pre-canned fonts, as seen here. And so these are all relative size fonts to the dynamic type size. So if you say you want a body font, then you'll get back this preferred body font, and that font will change as the user changes their dynamic type setting. And of course I've defaulted the preferred fonts to something appropriate for that particular control type, but it's overridable. Okay, so that's the control factory. The next thing I should point out is this cell disclosure accessory, which is a code taken and adapted from this URL here, so blog post. And the basic idea is that iOS allows table view cells to have what's called a disclosure accessory. It basically looks like a little greater than sign on the right hand side of the cell. However, it does not allow you to customize the color of that accessory, which is a bit lame. So basically, in order to get one that's colored the way we want it to be colored for our theme, we need our own custom class, and we use that from our table view cells. We use this class to make sure that they have the correctly colored disclosure accessory, and that's all there is to it. I mean, it's got a bunch of properties here, so you can customize the color and what have you. And then it's got the drawing logic there. Next up, I have this utility folder here with a bunch of stuff in it. I'm going to start with this layout. This code was taken originally from this GitHub gist here. It's written by Frank Kruger. And basically the idea of the code is that we can specify layout constraints, which is an iOS 6 onwards layout mechanism. We can specify those constraints as C# expressions rather than having to go through the process of newing up the constraints ourselves, and it's a bit laborious. So not only does this result in less code, but it's much clearer code. And we'll see that when we get to their views and we want to lay them out using the iOS auto layout subsystem. Now I have supplemented this code quite a bit. For example, this layout extensions I've added, baseline support I think it was, and a few other things. And also I've changed the class itself. Honestly, I can't remember what was in here originally, but I think I added these. And I also added support for more expression types in the C# expression. But you can have a look through this. It's quite hairy code. But I've cleaned it up as best I can, and it works. I've used it in several projects now, and it works. Couldn't live without it now. So view controller base is next. This is a base class for our view controllers, of course, and it's inheriting from reactive view controller because we're using reactive UI. And one of the things that we need in reactive UI is to implement this interface. And I just got tired of implementing it over and over for different view controllers. So I put this into a base class, and you give it the type of the view model, and it automatically implements that interface for you. Also, it comes with disposing support, just to make that easier as well, to save us having to new up our own composite disposable in every view. So that's nice. Table view controller base is a base class for table view controllers, again reactive, and again it implements this interface for you. It has support for disposing again, and it also has support for dynamic type changes, because when the user changes their dynamic type size, the table view has to kind of relay out. So it hooks into that and it takes care of it on your behalf. Here, reload data. And it also takes care of disposing when it disappears. It makes sure that subscription is gone and is re-established when it does appear. So next is auto size table view source, and this is a reactive table view source that automatically sizes the rows in the table according to their natural height, if you will. If you've worked in WPF, for example, you might take this kind of thing for granted. I certainly did when I started iOS development. But actually, you need to tell the table view controller what size your cells are, or what height they are. And this kind of takes care of that by automatically measuring the height for a row, and then using that height thereon. So it saves you the trouble of having to figure out what size your rows are and kind of hard coding that into your application. And lastly, table view cell base is another base class, but this time for table view cells. And again, we need to implement this iView for. And it also kind of dictates the life cycle for the cell, if you will. So it provides these three abstract methods that you must override in your cell logic. So we'll be making use of that at least a couple of times in our app. So that's the utility types. The last thing I wanted to go through was kind of the main code that runs when the application bootstraps. Now, first of all, I've changed the application class so that it has it hooks into the unhandled exception event for the app domain. The first thing it does is hook into that event, and when that event fires, it goes down to this handler here and it forwards the call onto this handle exception method. Now I've also wrapped the invocation of the actual iOS application logic here. I've wrapped that in a try catch as well and forward that on. To be honest, I'm not sure why I did that. I suspect I did some testing and found that an exception in here was not being raised through this event, but I'd have to test that again to be sure. Probably should have commented that. So either way, we end up calling this handle exception method. And in there, I'm newing up a logger service because remember, at this point, we don't even know that we have our IOC container configured. So we can't rely on the IOC container to get us our logger service. So I'm just newing one up manually, getting a logger and then logging the error. And if possible, I'm also using the container, the IOC container, to resolve the state service and store the details of the exception in the state service. And you'll see why I'm doing that in a second. In our app delegate class, I've changed this quite a bit as well. Basically, I've broken apart the steps taken during startup. So initialize the appearance manager, initialize Akavash, initialize IOC, and configure logging. I've got this checked for previous unhandled exceptions if we're in a debug build. And this is attempting to load any previous exception from the state service, which is what we just saw back in the main code here. So if it successfully loads an unhandled exception from a previous run, then it calls debugger.break. So hopefully the debugger would break here, and you'd see that last time you ran, there was some unhandled exception, and you'll get the full details of that exception. And then after that, we're just kind of doing the usual iOS thing of creating the UI window, and then I've got a simple view here, just a label with hello in it, and wrapping it all with a navigation controller because we're going to use the navigation controller to move from one view to the next and back again. And then, setting the root view controller to that navigation controller and then making it visible. Now, when the application enters the background, what I'm doing is kicking off a save of our state. So this save state async method uses the state service, or attempts to use the state service if it's available, to save the state. And we do that every time we background so that the state can be restored properly if the application is eventually terminated. So initialize appearance manager is very simple. We just call our configure on our appearance manager. Initialize Akavash is also simple. All we need to do is give it the application name. Initialize IOC, I've separated out into a separate couple of methods in a separate file because this is a partial class that we're in at the moment. So we'll get to that in a second. Configure logging. I am setting the threshold based on whether we're debug or not. And then I'm just subscribing to the entries observable, and quite frankly doing the wrong thing here. That should be system.diagnostics debug.writeline, because that way it will end up in the in NSLog. So that's it for this particular file, but as I say, this is partial, and I've separated the registrations out into this file, and I'm doing them manually. We do have the option of using the automatic registration in TinyIOC, but I've forgone that and done it manually because A, it's faster, and B, it kind of prevents, it's more explicit and it prevents us accidentally registering classes into the container that we didn't intend to. So it can avoid some problems there as well. And so here you can see registration of all the services. I'm only registering the one view model at this point because I think that's the only one that we'll need to resolve through the container. The other ones will be kind of newed up as part of the logic in that view model. But we can always go back and add it if we need to. And I've registered as a singleton. So the last thing I'll do here is just run the app in the simulator so we can see that firstly that it builds, and then secondly that it is correctly running. So there we go. You can see the yellow theme that I've chosen, and this space up here is primarily due to the navigation controller that I've got wrapping our view, and our view just has this hello label in there. So it builds, it runs, so that's good. So that's it really for the overview of the infrastructural code. So I will catch you in the next video. Bye.